Hello everyone, thank you all for joining us tonight. We are more than 700 people tonight here on site in Sunnyvale and also online. I know we have people joining us worldwide from Cambridge, Tokyo, Chennai, Vancouver, Sao Paulo, Bangalore, Tel Aviv, Singapore, and Barcelona. So I'll say good morning for those of you online who are on the other side of the planet. And my name is Pashu Christensen. I'm the Marketing and Partnership Manager for the Hive. We are all part of a community of over 3,000 people, practitioners, data scientists, thought leaders, entrepreneurs, designers, artists, all focused on big data. So we produce 2 or 3 events per month. We have a newsletter, we have a blog on hivedata.com. We host dinner discussions, hackathons, and we also sponsor big data research projects. The adventure started 9 months ago here in Palo Alto, and we are now expanding internationally. We have events coming up in Tokyo and another one coming up in Bangalore for the launch of the Hive. And we'll have upcoming events in Paris, Kuala Lumpur, and other countries in the world. We would like to thank our partners. We have a lot of experts coming from many companies and speakers, so thanks to them, we can put together these great events. We'd like to thank our sponsors, and of course, we'd like to thank NetApp, especially tonight, for hosting us. Also, we have new partners. One of them is Big Data World Show in Kuala Lumpur. They are going to host a huge event, a conference at the end of November. We'd love to talk to you. I know Ravi is going to give a short presentation about the Hive. Here is our contact information. And for tonight's event, for those of you in the room who can tweet, please use the Hive Data hashtag. And at the end of the event, we also have a raffle with a Strata ticket to win for Strata Hadoop World in New York. And we'll have 3 books to give away. So please stay around, and we'll have the raffle, and you have to be on site to win one of the prizes. Have a great night. Thank you very much. Bye-bye.
Perfect. So first, I'd like to just call upon Val Berkovici of NetApp. Val, come on. So we're very thankful to NetApp to host this event. Some of you have been to some of the previous events. I saw Dhruba somewhere around. Dhruba hosted a panel discussion, the Elephant Riders, I think it was called, which got a lot of different coverage. We've had other great events, all thanks to NetApp here and Val.
Thank you, Ravi. I really want to welcome everyone here. It's been another fantastic turnout. If I recall correctly, this is at least the 3rd time we've done a high-profile event like this. The first one made a lot of history because I think Dhruva did a fantastic job of creating a real Clash of the Titans atmosphere and generating one of these really entertaining panels as opposed to a boring one. The second one, we definitely made history because we were able to actually talk about the details of Facebook's graph search implementation just as it went public, only in the beta phase. It was a fantastic content-rich event. So based on those 2 strong precedents, I'm really looking forward to this tonight. And yeah, and we actually did the Harlem Shake, you know, of course. I had to go through that crazy wave. Are we doing a dance tonight? So I'm really looking forward to this particular panel discussion tonight. We've set really high precedents and a high bar. And again, NetApp is really proud to be associated with these events, so enjoy.
Thank you, Val. We also have partners with a desk out there, the O'Reilly folks. So if you get a chance, go put your business card in the fishbowl she has, because they're going to give away as drawings. The first prize is, I think, a free ticket to the Strata conference in New York, I think in October, if I'm not mistaken. And then they're giving away a bunch of books. So if you have a chance later, go and drop your card there. So with that, I'd like to tell you a little bit about the Hive. The Hive is early stage incubation entity. We incubate, we fund, we launch companies. And I'll talk more about that. In addition to that, we have the Hive think tank. We have many thousand members. Every Wednesday, at least 3 out of 4 Wednesdays, we have somewhere between 200 and 400 people. This time it's a little larger who come to these events on all aspects of big data, data infrastructure, data science, and so forth that Pashu talked about. We also have an innovation lab. So you'll see Lance. Where's Lance? Lance out here. Many of you who are from Yahoo and from the Hadoop community probably know Lance. And so he has built a little sandbox which allows different vendors, different people who have data, different device providers to integrate together. And so check it out. The Hive basically is, as I said, early stage incubation. So we have a bunch of operating people in the Hive who work closely with entrepreneurs to start companies. And in addition to sort of supporting them through operating experience, we fund them. So anywhere between $1.5 million to $3 million. Our focus, the slice of the big data market that we focus on, is applications. There are a number of great vendors, many of them here on the table and many others, who are doing a lot of cool things around infrastructure, around a lot of the processing, storage, middleware, and so our focus is different. Our focus is data-driven applications that can be either functional applications like CRM, marketing, security, supply chain, or vertical applications in the telco, energy, healthcare, and so on, different areas. That's our team. You'll see Craig and Sumant also behind in the room somewhere, and Pashu and myself, you know. Please do be part of the conversation today. The people who are online, if you want to ask questions, use the hashtag HiveData. And with that, I'd like to introduce tonight's event. For me, it's wonderful to see so many interested people, both here on site as well as online. The way I like to think about it, it's a kind of a marriage of sort of the old, proven SQL types and the kind of the young, flashy Hadoop types. And I think they need each other, or at least we'll find out if they need each other. Raghu Ramakrishnan, many of you know from either you were at Wisconsin or at Yahoo, has had a long career in this space. He's now a fellow. He's CTO of information services at Microsoft, and we couldn't have found a better moderator for this panel. So with that, I'd like to hand it over to Raghu.
All right, I'm mic'd. Excellent. Okay, so it's my great pleasure to be here. Thanks to the Hive for organizing this, and thanks to all of you for being here, and to all of you for being here. Without further ado, the format of this will be that we'll go through a round of introductions, and then everyone will speak briefly to present sort of the context for where they're coming from. And after that, we will have a discussion, right, internal to the panel. Following that, we'll throw the floor open for questions from you guys. So please save up questions, and all the hard ones, it doesn't matter, I'm the moderator. All the hard ones I'll send that way. Okay? So first, we have Sushil Kaushik here, who I personally knew first at Yahoo. And from there, he went to Greenplum, and they went through this name change. You know, just like Fair Oaks becomes Java Drive. It's pivotal. At Yahoo, he did something that was extremely relevant to this panel. He was the product team, he was the manager, the product manager for Hadoop there. And he also did some of the work, he also did the PM for some of the work that relied upon Hadoop. So he has a very interesting perspective. Okay, since you can read the rest of the details. Alan, again, I know Alan back from when he got involved in PIG. So PIG was something that happened at Yahoo Research. Chris Olston, Utkarsh, in Yahoo Research, they were at that time, Utkarsh was on my team. They did this research project, it got traction internally. Alan and the Hadoop product team members were the ones who stepped in and helped make it real and took it to where it is today. Beyond that, he's also responsible for HCatalog, and he was one of the founders of Hortonworks, and he's here representing Hortonworks tonight. And he'll tell us about some of the work he's been doing on making queries run faster in Hive. Tomer Shiran. So Tomer's lucky. He didn't have to know me previously. And he is the VP of product management at another Hadoop startup, MapR. And he will talk to us today about Apache Drill, and he is speaking here as a representative of MapR, where he's been since the last 4 years. Justin Erickson, he kind of got wind of the fact I was coming to Microsoft and skipped town a couple of months ahead of me. So I never really got to know him while he was there. He went to Cloudera, a great bunch of guys there. And at Microsoft, he actually worked on product management in the very group that I am in now. But now, so I guess he's a young and proven guy. Is that how it works, using Ravi's formula since he worked on SQL? I don't know. Anyway, now he works on HDFS, HBase, all the stuff that we are interested in here from the perspective of Cloudera. That's my parsing of Justin, so just the right man to represent Cloudera for us here. Okay, alrighty. And last but not least, I guess I have to say that, right? I can't say last and no. Okay, Priyank. Priyank is the director of product management at Teradata, at the Aster group in Teradata, and as such, he deals with the Hadoop portfolio of projects. So, oh, this is something I didn't know. He was the third employee working on building out the core product. That's excellent. Alrighty. So with that, let me get the ball rolling here. I must say, the Hive people who put together this panel managed to get an amazing group of people from a very, very in the mix group of companies. So I'm hoping for a very, very engaging panel today. So please. 3 minutes. And
I've been told 3 minutes, so I'll keep it short, very, very short. It's refreshing to see a big data problem in US also. I spent the last 1 year in India, and I thought India and China have a big data problem and nobody else. Anyways, enough of big data jokes. So imagine if you have to build an application. And I'm pretty sure everyone wants to come up with an app which has got hundreds of millions of users on it. You have to make trade-offs and you have to make choices. The startups on one side have to make different set of trade-offs. Enterprises have to make different set of trade-offs. So if you look at it, you have to decide what interfaces you're going to have, starting with the application interfaces to the data access interfaces to the data management interfaces. And then you have to worry about infrastructure as to how you're going to build your application, how will your software will be deployed on the platform, and things related to that. Now, the key goal is always the same. I want to get to the market fast, and in some cases, the goal is also to do it cheaply also. So if you look at it from a perspective of an enterprise, I've been working with a lot of enterprise customers, and if you look at it from an enterprise perspective, the challenges are very different compared to a startup. A startup has a clean slate. You can pick and choose whatever technologies you want, and you can define the cost structure for building your application any way you want it. But when you're looking at an enterprise, you already have an existing infrastructure in place, existing application team in place, existing operations and monitoring team in place. How do you fit in these new platforms into this existing ecosystem without creating a massive disruption is basically what enterprises are looking for. And that's what I find. They are looking for investment leverage. So how can their investment be leveraged? So what they're looking for, easy and transparent investment leverage. So whatever infrastructure they have, it should not become redundant next day, because a lot of applications rely on it. And enterprises cannot retire an application and start a new application in few minutes. They want to extend their existing architecture. They do not want to replace, but they want to extend. Few are very close to internet scale, by which I mean Yahoo and Facebook scale, but they do have scale. So it's not like enterprises don't have scale, they do have scale. Resource investment. I was talking to one customer, he has about 300 people who are only familiar with SQL. That's the only thing they've done. Now going with a platform like Hadoop and saying, okay, don't worry about SQL, but worry about the other interfaces is a big headache for them. Retraining 200 people is going to take 6 months or a year of disruption, which he cannot afford. So our recommendation is stay with the legacy interfaces. And business transformation. This is about an application needs to be adopted by the business. How are the end users going to use the application? That's what they're focusing on. And finally, lifespan. Startups have a different lifespan, enterprises have a different lifespan when they're building applications. Anyway, so what the net is that enterprise finds SQL to be very expressive for complex data analytics. It can do most of the things or almost all of the things they want to do, and with the advent of adding analytics also as part of the SQL engines, it is making their lives very easy. So what we have from Pivotal, I mean, of course, I cannot talk about all of these things and not talk about Pivotal. What we have is Hawk. This is a database which is the traditional Greenplum database, which has been ported onto Hadoop. So imagine you can do read and writes directly off of HDFS, and it brings you the investment, 10 years of investment which Pivotal has made onto the database available to the enterprise customers. So we're talking about high query performance. We're talking about interactive query times. We're talking about an enterprise class database which comes with column storage. All kinds of complex joins are possible. Cost-based query planner so that it can do things pretty good. Security, workload management, and all the standard capabilities. And then on top of that, you have comprehensive data management, which means you have all the set of partners who integrate with the platform, and multi-level partitioning also is available. Anyways, so we'll have a lot more discussion on these key features from us as we progress in the presentation.
Thank you, sir.
All right. Thank you. So I guess I'm one of the young Hadoop guys, though, working at a startup in Silicon Valley and being one of the few people in the company who is actually programming in the last century. I don't get called young very often, so that was kind of refreshing. I enjoyed that. That was a nice start to the discussion. Thank you. So I wanted to talk a little bit about what we're doing at Hortonworks around SQL and Hadoop. As Sushil said, everybody still wants SQL, right? Hadoop is great. It brings lots of new paradigms, lots of new tools, but that doesn't mean you throw away the old. You use both. And I think everybody agrees on that now. We see that SQL is a great thing. So there's lots of different approaches to this. How do you take SQL onto Hadoop in a way that meets the performance and features that people are used to, right? They don't want to step way back in time to SQL of a long time ago. They want the SQL they're used to today, and they want that to work with Hadoop. And you'll hear about a number of those approaches tonight. And I want to talk a little bit about the approach Hortonworks is taking. So we started up an initiative called Stinger to do this work. And our view on this is that Hive is already the tool to do SQL on Hadoop, and it's already very good at what it does, which is large batch SQL. And rather than start over and build yet another SQL system or try to adapt an existing SQL system to it, what we have set out to do is take Hive and make it so it works not only at that big batch level, where it already is, but also works very well for these other use cases that people have, right? So that has two main thrusts to it. We started out by making this very brash promise that we would make Hive go 100 times faster than it did in Hive 0.10. And that would put it in the kind of time frames that people are used to doing ad hoc queries with. You want a user to be able to sit there, type a query, and get a response back right away, right? That's not the experience you have today if you use Hadoop, but we believe we can create that experience. And second, we want to take the SQL that Hive has and expand that to have the features everybody wants, right? Hive was built in a world where it was mostly focused on large batch jobs, so that influenced what SQL features it had, mostly very basic ones. But it doesn't meet a lot of the requirements that people have when they want to connect it to their BI tools, when they want their analysts who are SQL, heavy-duty SQL users to use it. All those things, it's missing those features those people expect and need. So we've set out to say we're going to add those in. And our goal at the end is that we do have one system that you as a user, you as an administrator, don't have to sit and think about what's the right solution, what's the right tool to use for my query, right? All you have to do is go, I know I go to Hive, I type my query, it figures out whether I need to run this like a big batch job because it's going to take 3 hours, or I need to run this using the tools I have to do very quick queries because I'm estimating this query is going to finish in 2 seconds or 5 seconds or whatever. Right? So that's our goal. Of course, Rome wasn't built in a day. This isn't going to happen overnight. So this is getting rolled out in phases. And I'm not going to go through all these because I've only got 3 minutes. I probably have 2 minutes less than that by now. So I just want to stress that this is this is something that's coming out over time. Stage 1 has already been released, and we've released some benchmarks for that. Some of our competitors have, and I have to say that given how long we've been working on this and how far we have to go, I'm very happy with where those benchmarks are. We sped up a number of queries 5 to 10x just in phase 1 of Stinger. And when you set out and say, we're going to speed up things 100x, it's really nice when you get a very good bump in the first stage, and we expect similar results from the additional stages. So phase 1 of Stinger still works on Hadoop 1, still MapReduce based. In phase 2, we're really moving this to take advantage of all the wonderful things we can do with Hadoop 2. Hadoop 2 frees us from the MapReduce paradigm, enables us to write an execution engine that will be optimized for what Hive, Pig, cascading, those kinds of tools need, and we believe can move much faster. And then as we move into phase 3, you'll see a lot of things that traditional databases do and have. All right. That's my, excellent. Thank you. Now we'll do this dance
again. Okay, good. So thanks to the Hive, thanks to all of you for coming here, and especially to I heard being from Israel, the folks in Tel Aviv, they woke up at 5 a.m. to watch a SQL panel, so they must be really interested in the space. So I wanted to talk a little bit about this SQL and Hadoop space, and I think the first thing you've all noticed is that SQL is hot again, right? It's been 30 years since that's been the case. And we see over a dozen different SQL projects, and that includes things like Apache Hive, and obviously the very exciting work happening in the community to make that a lot faster. There's a project called Apache Drill, which is kind of that next generation of SQL and Hadoop. And we see other projects like Impala and Shark and Hawk or Greenplum, cascading, and Splice Machine more on the OLTP side. So a lot of exciting work happening in this SQL space. And our approach at MapR is really all about providing the broadest support for SQL. So all of these tools have their strengths and weaknesses, and I think the key is that the customers have to choose the right tool for the right job. They have to look at their requirements and make that the right choice. And so we're really excited to bring all these technologies to our customers. And the first one we've done that with is Hive 11, and our customers are enjoying that 5 to 10x bump in performance. So that's been great work that's happened in the community. We're right now in private beta with Impala. It's already running 25 to 50% faster on MapR compared to other distributions. And so we're also very excited about that, and we'll bring that to customers in the next few weeks. And then we'll see the first alpha release of Apache Drill 1.0 by the end of this month. So a lot of interesting work happening, and really excited to be exposing all these different technologies to our users. And then with that said, I also wanted to mention that there are some very interesting technologies and products out there for interactive analysis of data and data exploration. And specifically Datamir and Platfora are doing very, very interesting things with with Hadoop that go beyond what SQL queries can do. So things like showing you anomalies and classifiers and recommendation technologies. So why Apache Drill? I think the first reason is we wanted to start a community-driven project. We, at MapR, we're all about bringing open source technology to our customers. We have over 15 different open source projects in the distribution, and avoiding vendor lock-in is key to our strategy. Our customers don't want that, and so we realized that SQL is a customer-facing technology. It's a user or an application-facing interface, and as you all know, going from, let's say you went from Sybase to Oracle would be 2 years, a 2-year migration. So, obviously there's no compatibility between different SQL implementations, and so that was a clear choice to make Drill an Apache project and a community-driven project. If we look at the merits of Drill itself, it's all about bringing that next generation of SQL and Hadoop, full ANSI SQL support. HiveQL is not sufficient. There are a lot of tools out there, BI tools, visualization technologies that support standard SQL, and that's really key. And then if you look at other things that have made Hadoop popular in the first place, like kind of optional schemas, that's what Drill is about. You can take a JSON file and you can query it without predefining and managing schemas. You can just take that and query it. You can take an HBase table without defining a predefined schema in the Hive metastore and just query that HBase table. So this is really taking this to the next level in terms of what you can do. And then things like nested data and a lot of extensibility points. And if you look at what we've been able to accomplish so far, over 100,000 lines of code developed already in companies like MapR, Oracle, Microsoft, several universities have all contributed code to this project. So a lot of interesting work going on there. And then I'll wrap this up by saying, for those who have used Hadoop and those who have leveraged big data technologies, it's not just about queries. Hadoop is about a lot more than SQL. Our customers are building recommendation engines, they're doing fraud detection, they're building virus signatures, recommending coupons. They're doing all sorts of different things with this behavioral and big data. And it takes a lot more than just making an interactive SQL engine. For example, you have to be able to provide real-time data loading so that data in the cluster is fresh data. It's not an hour old, so that you're doing interactive queries on data that's not stale. And as you all know, HDFS was really not designed for these workloads. It was designed for as a repository for web pages for the Nudge crawler, and it just can't achieve these goals. We're really excited about Yarn and the MapR storage layer, providing that enterprise-grade storage for all these different workloads of big data on a single platform, and that requires all these enterprise-grade capabilities, multi-tenancy, and full read-write support. So that's kind of at a high level what Drill and MapR is doing.
Thanks much, Kumar. In about 3 minutes, I'll leave my fingers. Sorry? In about 3 minutes. Okay, that's good. Hello, everyone. I'm Justin Erickson. I'm a product manager at Cloudera. Before I dive into our vision and our view on SQL and Hadoop, I'd like to call out the broader picture that SQL on Hadoop, while very important and incredibly exciting over the past several months since we launched the Impala project back in October, the story here is not just about rebuilding the old world in a cheaper and different way. The story here is about building the new big data platform where the data itself has gravity, where you have a single platform that you can use the same data set, same resource management, across multiple different processing frameworks depending on what your needs are. So you get the core of your batch processing with technologies such as Hive, Pig, and of course MapReduce itself. You have interactive SQL through Impala. You have interactive search through Cloudera's new search offering. And through many other partnerships and additional developments, you'll get analytics such as SAS and R that run natively on the CDH platform. In order for all these frameworks to work and be native big data solutions, they all need to be able to scale from tens of machines to thousands of servers simply by throwing machines at the problem. Not have upfront schema so I can dump in data and then later when I want to figure out how I want to analyze it, at that point determine how I'm going to look at that data set. And if I'm looking at big data, I cannot afford to do that at the price points of traditional data management solutions. If
I'm looking at the next platform that I'm betting my business as I'm starting to build my data reservoir, data lake, or whatever term you want around that, the power of open source and the ability to try the technology, use it, and then figure out how you best want to support it, whether it is through a vendor like Cloudera, whether it's through yourself, or whether you choose a different vendor. Now into the interactive SQL on Hadoop. Impala is a project that we launched back in October of, publicly unveiled back in October of last year, that gives interactive SQL. The key thing here in any system, faster is always better. But what makes this exciting is that fundamental shift, wherein the old world with Hive, I'm executing a query, I'm not going to sit there and wait many minutes for that response. I will context switch to something else, come back to that at some point later in my day job, and then look at the results and figure out what my next step is. With a technology like Impala, where you now get responses in seconds, it is completely feasible for you to come up with a hypothesis, execute that query, look at the results, and iterate until you find that novel business insight or until you determine that your hypothesis was incorrect. Gives you a standard SQL interface that brings the thousands of trained users in your enterprise, makes them approachable to them. Of course, you look at the first two bullet points and you say there's plenty of systems today in the legacy world that provide interactive SQL and higher levels of SQL compliance. The thing that makes Impala truly unique amongst all its peers is it's the only engine that gives you interactive SQL natively on Hadoop and HBase. What I mean by that is you get the same flexibility, scale, and cost advantages where I can run the same data on the same across multiple frameworks at the same time, including Impala. To do this, Hive was designed and great for batch, inspired by the Tenzing project and built by Facebook. And as you see, as Google built Dremel outside of the Hive their Tenzing project, and Facebook recently launched the Presto project. Low latency has a different sets of requirements. The key thing, I'm running out of a little bit of time here, but the key thing that makes Impala unique is it's available today, proven across multiple customers, to unlock BI and analytics right now. To do this, you need responses in seconds, level of concurrency where I can deal with hundreds of users and maintain the native Hadoop principles of the native flexibility of no data migration, conversion, or duplication, can run across the native existing file formats as well as provide best-of-breed formats. And fully integrated with the rest of the Hadoop ecosystem. So same storage, same metadata, same security, and now with Sentry you get enterprise-grade access, role-based and fine-grained access controls. And of course, all this is available through an Apache license open source. Thank you.
Thanks.
So I wanted to start out with Teradata's view of the enterprise architecture and how we view it as evolving in the next decade. It's clear, and the reason that so many people are here is it's clear that Hadoop is a big force which is actually being used as a very effective data processing platform, not just here in the valley, but also outside the valley. And what we see at Teradata is that Hadoop becomes a very interesting and very, very cost-effective data management platform as an enterprise evolves their existing 20-year-old framework of a mature data warehouse into adopting a Hadoop system. And that's how we integrate and we talk about the unified data architecture at Teradata, where we talk about the Hadoop system and we integrate into the Hadoop system as a very effective and scalable, cost-effective data management layer. And as the Teradata system as the integrated warehouse, which is your system of record, which is going to serve your hundreds or even thousands of concurrent BI users, concurrent analytic users at the same time with its mature capabilities. In addition, what we see enterprises do effectively today is combine SQL and MapReduce and analytics on MapReduce to not just to say that, hey, MapReduce is slow, I'm just going to look at just SQL for analytics, or just forget about SQL and just start coding everything in Java, but effectively blend the two to get analytics which are beyond what you can do in the BI and in the BI space today. And that is what we solve in the Aster Discovery platform, with our rethinking of the SQL extensions to MapReduce, which is called SQL MapReduce. So the portfolio for Hadoop Teradata provides a vast or a wide range of services and a wide range of products around Hadoop. We provide an appliance, a prepackaged appliance to solve the management issues that exist around Hadoop as it matures going forward. We work closely with partners in all distributions, MapR, Hortonworks, Cloudera. In this specific appliance, we OEM the Hortonworks distribution, which is the well, it's actually the only true community-driven distribution anymore. And we provide a lot of analytic services around it to be able to integrate this and evolve the existing infrastructure at enterprises into the future. The glue between the Teradata and Aster analytic platforms and the discovery platforms with the Hadoop system, or the data which is actually landing and being stored in the Hadoop system, is with technology called SQLH, which we came out with about 2 years ago. And the idea was to make sure that whatever whatever processing work, analytic work which is being done and enabled by these new projects, whether it's Hive Rethought, or it's Impala or Drill in the future, when that data is done being processed over there, it can be leveraged, it can be merged with the rest of the applications that are being driven by the Teradata system, by the Aster systems. And that's where SQLH came about, where it integrates at the metadata layer with the Apache HCatalog project, understands how the different applications on top of Hadoop are modeling the data and storing it on HDFS, and then it parallelly reads that data from the HDFS file system and integrates at runtime into the Aster or into the Teradata systems. And that's what SQLH does. It gives you a quick way to start accessing your data which has been stored inside Hadoop without necessarily going through a new tool and learning a new interface, a query interface, whether it's a SQL-like interface, whether it's almost SQL 92, whether it's going to be SQL 2003 next year. That's it.
Thank you so much. Okay. Well, okay. So one thing that you have seen from several of the speakers is the worldview. It's a common worldview. So I like to call this the digital shoebox, okay? And the bottom line is, from a customer's perspective, I think where the world is shifting is the following. You're not really going to win the next database battle by delivering a SQL product that's 20% faster than your previous SQL product, okay? Or delivering a BI tool that's 20% faster than your previous generation. The thing that's happening here is convergence. People are looking at storing an incredible variety of data, and some of that data, the volumes ramp up exponentially fast. Machine exhaust is trivial to collect, okay? It's not necessarily of the same value per byte as your transactional data, but nonetheless, you have this heterogeneity of data, and you use it for a very wide range of purposes. And in terms of analysis, you're creating these composite workflows where at different points in the workflow, you're doing everything from simple data loading to SQL to interactive exploration to predictive analytics, training, scoring, the whole works. And you're looking to be able to do this kind of work without the impedance mismatch of moving your data across different silos, okay? And if you look at several of the speakers, they had a picture that looked pretty much like this. From the user's point of view, a place where you can keep this wide variety of data. Don't necessarily make the assumption that users will put all their data in the one place that you provide. They'll also want federated access to data that's in other places which they have ring-fenced for a variety of reasons. Maybe because it's on-prem data that they want to keep on-prem and combine with other data that's on the cloud. Maybe it's because it's data in a system that can't be migrated easily for reasons like privacy and auditing, but federation is going to be important. That said, logically, it's one place. Second, they're going to want to build analytic tools for everything: SQL, batch and interactive, stream processing, business intelligence, all the BI tools you hear about, machine learning, on and on, right? And one of the things I conjecture is, over the next few years, we are going to see a technology convergence as well. If you're going to see this kind of ecosystem, people can't afford the overhead of building each of these analytic stacks as a standalone silo. And again, I think we're already seeing some signs of that, right? Systems like HDFS, think of them as a starting point for a scalable store that supports a diversity of data. Then you think about appropriate formats and ways of shredding higher level abstractions like tables into these lower level files. In terms of computation, resource managers like Yarn, everyone sees the opportunity to leverage this layer without necessarily reducing everything to a translation of the program into MapReduce. You're going to see lots of these analytic stacks directly layering on top of Yarn, bypassing the MapReduce layer, right? These are trends that I see happening. And not only do you want all this, some of the capabilities you get in the enterprise today, controlled sharing, collaboration, you'll want to carry all of that over into this new world. Okay, that's the worldview. Next, let me say a couple of things about where Microsoft is headed with regards to this, and I'll be very brief. There are a couple of products out there. I encourage you to go look at the sites for more detail. Polybase is a Hawk-like product where essentially you can run SQL queries over a combination of data in a massively parallel traditional relational system and data in HDFS, okay, without necessarily first importing the data from HDFS into the parallel data warehouse. Power BI, there's a suite of tools, right, aimed at interactive discovery and exploration. So if you, all of these, by the way, allow you to use Excel as the endpoint, but this is not your grandfather's Excel, right? This is Excel with extensions, which is what I'm talking about, okay? That let you do things like roll up, drill down, that's Power Pivot. Power Query lets you discover other data sources, a Twitter feed that you have access to perhaps, right? And be able to query that directly from the Power Star tools in your Excel endpoint. And Power View is the visualization component in this suite. So net-net, all of this integrated with your SQL endpoint, which in turn now runs over your traditional SQL backend and Hadoop. This is sort of the picture that's coming together. Hadoop. This is something where we have jumped in with both feet, and for those of you who haven't tracked Microsoft lately, we are embracing Apache wholeheartedly. HD Insight is our AMR-like Hadoop on Azure cloud service. And in terms of how we are engaging with Apache, some of the things that Alan mentioned, we are working with Hortonworks on, specifically the awk file improvements and the vectorization work. And obviously, all of that work is headed for Apache open sourcing. We've also done a fair bit of work on making Yarn better in the area of adding support for checkpointing and preemption that leverages the checkpointing. All of that has actually been committed already. And lastly, there is a project that we've been working on for the past year, which we are getting pretty close to open sourcing. In anticipation of this next generation of suite and application tool development on top of Yarn, we thought about how to make that easier. Yarn gives you resource management, but the containers that you get, making them easier to program would go a long way in letting you build these different silos with less repeated work. Okay, and this is just, I'm not going to say anything more. We really are committing stuff. With that, let me stop here. And now I go back to that very first slide. This marks the end of the first phase of this panel. Next, we segue into the one where we actually talk about some of these questions. So the questions are, why is SQL on Hadoop attracting so much attention now? Okay. Well, my own take is, now that you're transitioning to the point where you actually need to make money, you look at the guys who are willing to pay money. And those are the traditional enterprises with deep pockets. And the first question they ask is, well, all my guys know SQL. What can you do for me? I would love to see what folks here think about this. Anyone want to comment on why SQL on Hadoop is heating up at this point in time? Please.
I'd like to quickly summarize
Priyank?
it. Yeah, I'd like to quickly summarize our response by we said so. We said so 5 years ago when we actually blended SQL and MapReduce in the Aster database, in how we evolved the Aster database. And it was pretty clear to us then that if there has to be wide adoption of the new paradigm with MapReduce, there has to be an interface which is an evolution with what people are trained to do, with what people are used to. That doesn't mean that MapReduce is not going to unlock and enable a new way of analyzing your data. It just means that you have to create a path for adoption, and that's why SQL on Hadoop, in my opinion, is now attracting so much attention.
Justin, you wanted to comment?
Sure. So I'd say as you look at where Hadoop started, it started around batch processing. And as more data came into this scalable system, people started wanting to do more with it. The higher level languages opened up not just developers, but through Hive you could get SQL users to construct things. Through Pig you can go and get a higher level language that you can program against that. So natural extension, as more data is available to me that I want to go and do more things with that. And this was the first foray into the beyond batch. And so as people had more needs to go into the real-time interactions, SQL and the traditional database space has historically been the answer for how I interact with my data set. And that's been quite exciting. So you look into the ways that people interact with systems and data today, you'll typically look at the most common ways are through SQL, through an analytics engine such as like a SAS or Revolution Analytics. And with Google, people are now getting more and more familiar with just free-form search against the data as well.
Actually, you made a great point there. Beyond the fact that there are so many people who are familiar with SQL, there are so many tools that are integrated with SQL as the endpoint. Great point. Please.
The perspective which I bring in here is that when Hadoop started, everyone was talking about unstructured data. Everyone said we need to do unstructured analytics, understand what the unstructured data is. And what was effectively happening was you are hiding the complexity of the structure of the data in code. So people were writing code and saying that this is what my data looks like. Why? Because I know it. Soon the enterprises started realizing that at the end of the day, most of the analytics is happening on structured data. Unless you understand what the data is, you cannot make sense out of it. And the paradigm that is shifting back towards is defining the structure of what you're going to analyze upfront, and then using the SQL as your favorite tool for analyzing the same data.
Do you want to comment on that, someone? I'm not sure I agree with that, but
yeah, I would
give others a chance to pick on you first.
I would challenge that a little bit. I mean, I agree that there is structured data with a lot of value, and SQL makes a lot of sense in that case. But I don't think it's just that people are shifting away from doing unstructured data or shifting away from doing some of that in the code. I think they're realizing that when you put all that together, when you co-locate that data, there are all kinds of new opportunities, right? So SQL is great for some of those problems, and it's not so great for others. So you do graph processing or whatever is the right approach there, right? But storing all that together has a lot of value instead of having to have some here and some there, and you end up spending time moving your data back and forth when you want to join it and all those pieces. So I actually expect I think you're right that part of the reason we're seeing SQL be hot now is because the people with money want SQL, right? But I actually think that's a great thing for Hadoop, because as Hadoop comes into these places where they will start with SQL, because that is what they know, that's what they've been doing for 20 years, as that happens, what we see happening is people discover more and more, oh look, now that I have this thing, I can do all this other stuff I never dreamed possible. So it's almost like SQL becomes the entry point for them rather than the end point.
Tomer, you wanted to say something?
I think, I think unlike maybe the legacy vendors here, I don't think people want to go back 10 years in time. I think we're actually, this is about taking it kind of to the next step. And really what's happened is Hadoop has become kind of the pervasive big data platform where companies have all their data in this platform. And they're doing a lot of things with it, just like you mentioned, right? They're doing machine learning, they're doing recommendations, they're doing BI. And I think one of the things people want to do naturally is they want to interactively explore that data. They want to, look at that log file of event data that's come in and say, show me how many, or give me all the records that were an error and happened in the last day in my data center in San Jose. So I think it's just natural that people want to have that kind of ability to do an interactive query on that data. But I definitely don't think it's about taking just database technology and kind of putting it on Hadoop. I think it's a lot more than that.
I would tend to agree with that. I think what's happening here is there's this whole pattern of information production that's coming in. As you look at data like machine exhaust or web logs, it's inherently unstructured, but there's some part of it that is structured that you want to get at. And once you get at it, you will do various things, including a lot of SQL processing, but not limited to it. And at the end of the day, at each stage, the intermediate data you get itself becomes grist for another phase of the production life cycle. By the way, there's one other reason why SQL on Hadoop is, I think, gathering some attention. Us older SQL guys want to feel young, so we work on Hadoop. Okay, I think that's pretty much, we are in sync. But technically, I didn't see a whole lot of agreement. I saw some elements. It seemed that a lot of people were clear that they wanted to bypass MapReduce, translation into MapReduce, and build native SQL implementations. I also saw Yarn mentioned in a number of slides, right? By the way, while I didn't mention Yarn explicit, I did, sorry. We are also using Yarn. There's still a fair amount of diversity in the technical approaches represented at this table. So I'd like to see what people have to say on this. Why are people not satisfied with the old implementation of Hive and Pig? One obvious answer would seem to be interactivity. But is that it? If you were concerned solely with batch processing, would you settle for the old implementations? What do people think? Alan?
No, so actually you referenced me working on Pig. From the beginning of working on Pig, I remember having discussions with the MapReduce guys and saying, we need to make changes to this. This isn't the right paradigm for what we're trying to do. MapReduce is a great paradigm for a certain set of things, but it's not, for any of you who've written code to implement joins in MapReduce, which I've done a number of times now, it's not a natural fit, right? You're cramming a square peg in a round hole there. And so it's not just about interactivity. Certainly interactivity is part of it, and that's why we're working on Tez to build an execution engine that is the right basis for it, for Pig and Hive and those kinds of things, right? But that's not the only piece. There's also things about, you want an operator set in your execution engine that's going to match what your processor is trying to do. You want joins and unions and all those things to be natural fits into your execution layer.
Do others want to speak on this?
I'd say the first thing is, even with something like Hive, we have to take that to the SQL standard. There's just so many tools out there that speak SQL and not HiveQL that in itself is a challenge. And you talked about tools being the ones that are generating SQL. I think the vast majority of SQL in the world is generated by tools, things like Tableau and QuickView and Excel and other tools, right? So, I think that's one thing. Regardless of batch or interactive, you have to take that to the SQL standard. And I think MapReduce and Hive are actually very good tools for batch processing. I think we have hundreds of companies that are using our distribution with those technologies and with a lot of success. So I wouldn't go stand up here and say that those tools aren't good for batch processing. I think what they're not suitable for is that query that's going to take 50 milliseconds or maybe a few seconds. They're just not designed for that, and that's why we're seeing these new technologies come up to address that use case.
So let me actually push the panel on this notion of interactivity. Everyone here is hot on the idea of building a SQL for interactive use, which loosely is defined as something where you expect answers back in seconds. Well, if you take the whole class of BI tools, right, they have identified a very large sweet spot of queries where you want this kind of interactivity, roll up, drill down, pivot, all these operations. And for which they also have a nice UI metaphor. So you can have front ends that someone who doesn't know SQL, and amazingly there are people who don't know SQL, they can actually use this. right? So the question I have for you is this. If you take many of those systems, they're blazingly fast because they have many years of optimization with in-memory representations and the like. And with all due respect, none of the SQL stuff on Hadoop that we're talking about, including stuff that we're working in, and this is not about any one of you in particular, is close to matching the performance of those BI tools when you're in that sweet spot, right? So what are your thoughts? What are the examples of interactive SQL that you're seeing customers demand that fall outside this big, rosy BI sweet spot? Justin?
Yeah, so I think when you look into how things have traditionally been done, you get a lot of pre-aggregations and sampling where you're looking at a narrower set of data rather than the full fidelity or all the data being available to you. And therefore, I can take more of that data system, put it into that optimized structure, and on the BI side, put it into in-memory caches to go and look at that. Perfectly fine for the really high-value data sets. Much more difficult if I'm trying to take advantage of all the data that is available to my enterprise. When I'm trying to not just look at the bought and sold transactions, but I'm trying to look at the user behavior as they navigated through my website or navigated through my store, or if you're looking in other industries, similar other metaphors there. That data volume starts now growing exponentially very quickly, and you can continue to try to find a system that can fit all your data in memory on the BI side, or try to go and pre-aggregate and load that into these summarized cubes. But at some point, you're trying to push a rock uphill. You're either running out of the capacity of a machine to be able to hold that much data, or you're also confining yourself due to process and overhead of trying to convert that into that structured format. So the advantage of what you can do with SQL on Hadoop is I still get the advantage of a fully scalable HDFS file system underneath, and the value of interactivity is I can actually get interactive SQL against that raw data before I bring it into my operational store. And this isn't to say that those operational stores, such as the traditional data warehouses, go away, but it is to say that you can do the exploratory interactive analytics. When I'm trying to find the next diapers and beer analogy, I can do that directly against my raw data and don't have to surmise what subsets of my data am I going to pull into those specialized engines.
So is it only scalability?
Or
is it also the language surface? Because if you look at these BI tools, they are essentially translate into collections of group by queries, subsets of SQL. So your answer I parse as essentially the scale dimension is one thing, right? Okay. But what about the language surface? Do you think you need to go beyond the group by subsets that you get from these BI front ends?
Sure, I'd say that there's actually three things as part of that. One is obviously scale, to be able to go to petabytes of information. Cost is a factor in that, but I'd sort of put them in a very similar bucket, that if I'm looking at storing petabytes of information for me to go and explore, I don't want to do that at tens of thousands of dollars per terabyte. Well, I do want to do that for that high-value data that I'm getting pinged over and over and over again. The last one, which actually is the most important in my opinion, is the flexibility of the framework. The ability to do schema on read and have any of the data loaded up front, readily available for me to go and say, this is what the data looks like, and then perform the analytics on top of that, enables me to have the data there just in case. And we have many customers who have come to us, and a lot of the impetus behind Impala and Search is customers saying, I know I'm collecting all the right data. Now I just need to figure out how to open it up to my end user base. And that paradigm shift where I can have the data there, and now I can say, okay, let me define what this looks like, and now run a SQL query on top of that, can open up another level of flexibility that wasn't really achievable in the past.
Yeah, I think it's more about eliminating connectors than it is about necessarily just scale, right? Because at the end of the day, if you're going to have 100 analysts and each one is going to run a query on a petabyte of data, your cluster will be down within 10 seconds. So I don't think that's it's really about, I have one platform and I'm running a MapReduce job and I want to be able to do interactive queries on the results of that MapReduce job or the results of my running my classifier or something like that. And I want to be able to query that data without using a connector. And I think we saw some of the slides earlier that had, I counted 3 connectors in one slide, and that's just not going to work. You can't be in the business of moving data between different systems, whether they're backed by that same HDFS or not. If you're having to move data into a different system, if I have to take a an event log or a log file that was generated by my MapReduce job or my Hive query, and then go do insert into our relational system. That's just not going to work. You're introducing a lot of latency, a ton of complexity. You're losing the lineage of the data. I mean, there's so many problems that are going to happen as a result. And I think this whole movement for SQL on Hadoop or SQL in Hadoop is all about eliminating those connectors and having one platform, which is kind of that store of record, and you do the different workloads on that data where it is.
Great.
So coming back to the point where you started the discussion was that the BI vendors have solved the problem of doing planned analytics very well, which means planned analysis of your business, planned analysis of how you're operating your refineries or whatever you have very well. What they have not done well is ad hoc analysis. A question which does not fall in the standard pattern, it's very hard to solve. And what people are looking for is to answer those tough questions if and when they arise. So what people are looking for is interactivity for ad hoc analysis.
Great. Priyank, please.
I think I'd like to respond to Tomer's point about the only reason we want to do SQL on Hadoop is because we want to eliminate connectors. I think that's a very narrow way to look at the problem, specifically because when you just narrow down or when you just dumb down the use cases that customers want to run on data, whether it's in Hadoop or elsewhere, to saying that it's a bunch of group bys or a bunch of SQL relational algebra commands, you are essentially saying that if that's the only way to solve the problem, then you are doing injustice to the kind of analytics that customers are running. As an example, and this is happening in the community as well as outside the Hadoop platform. There are projects which are based on Google Spragle, for example, the graph engine, and there are other vendors who are actually talking about doing dedicated graph analysis, processing multi-billion node graphs or multi-billion edge graphs. I'm sorry. On the data. And this is not about saying, hey, I could do SQL on the Hadoop platform, therefore you better not move that multi-billion edge graph into a platform that can calculate that can do the analysis.
That's a fair point.
Yeah.
So you can't just say no connectors, but
absolutely. And I think
minimizing connectors is probably where
minimizing the movement of the data. Yeah, absolutely. That's the right way to go, but
so,
not to say that it won't exist.
Agreed. The next issue we wanted to touch on was SQL standards, and we already sort of edged into that one. SQL standard compliance, whether we like it or not, it's not flashy, but it's important because of the ecosystem of people and tools, right? What are the thoughts of this group of people on SQL standard compliance? How committed is your company to it? How much are you investing in just making the edges fit?
We have a simple answer. We are 100% ANSI compliant, so.
With what packages?
No packages. We have the Hog database. It's compliant with ANSI SQL. So any statement you have, it should run on Greenplum.
See, so
I'll let you.
Can I jump? This is actually quite fun. I was prepared for this one. I'm reading from the Greenplum user document here.
Go, Justin.
I was waiting for this. Sorry, you stepped on a little bit of a landmine, but it was just too much fun.
I hope you're prepared.
It is important to note that there is no commercial database systems that are fully compliant with the SQL standard. Greenplum database is almost fully compliant with the SQL 92 standard, with most of the features in the 99 standard. Several features from the SQL 2003 have also been implemented.
This is what I was asking about packages for. They enter in the 99 standard.
But on a more serious note, I'm sorry, you stepped on a little bit of a landmine, but I've seen
point aside, look, at the end of the day, the 92 standard is a good baseline to start from, right? What about Impala? How close is it to being 92 compliant?
So our approach is, the goal of a standard is to make sure it works with all the BI tools and what you're trying to get out of that tool. When you look at the SQL standard, it's built to be all the different things that you can do with SQL. When we're trying to build an analytics engine, do you really care about having triggers on your engine? There's places where that might be useful. So our approach is to go and build the functionality that is being used by the BI tools. Not necessarily to hit a standard checkbox just for the sake of it, as you can see, as is actually Greenplum's implementation. And we're not going to just go from, let's go do 92, then let's do 99, let's do 2003. We'll see 92. We have the overwhelming majority of that standard. The key piece that you actually could use for analytics that is not yet there in Impala and is definitely part of the roadmap is correlated subqueries, and they'll be added in shortly. But once that's done, the rest of the SQL 92 standard is a lot less meaningful. After that, and actually we already started work on things from the 2003 standard, such as rank and aggregates over partition, window functions as they're traditionally called. And then there's also things from the 99 standard in terms of the analytic functions, such as rollup, cube, and so on and so forth, that will also be added in. But we're not going to, our goal has not been to go and hit a standard just to say that we've completed a standard, but our goal is to go and hit the requirements and functionality across the standards in the order that they're most prevalently used. And ultimately the goal is that you as an end user of a traditional BI tool or a new BI tool do not have to think about how do I go and do this for this engine versus this other engine, that all the functionality you expect just works out of the box.
So Justin's answer is we are not that concerned about SQL standard compliance for its own sake.
Yes.
Thomas?
Yeah, so I think what's interesting here is the first fact to point out, right, is going from Greenplum to Teradata to Exadata, each of those steps is going to take you 1 year to do as an enterprise, right? It's while there is a SQL standard, they're not exactly the same. That's true. At the same time, you know, there's a level of SQL compliance, right? And I think being able to, for example, run the TPCH standard as a basis, which is, you know, something that's out there. I mean, that should be pretty easy to accomplish because you can see those queries, right? It's not like saying, okay, what is my you know, retailer or you know, financial services customer running, and they have 1,000 analysts and they're running all their crazy queries. I can't necessarily, you know, anticipate that, but I can certainly anticipate the TCPH standard. And if I can't run those queries, then obviously I'm not at the level of compliance that customers expect to be at. So I think we do need to aim to be very, very, you know, a lot closer to the standard than what HiveQL can provide today or what Impala can provide. That's for sure.
I think Tomer hit it on the head. There is an ANSI standard, but every database has its own flavor, and it takes a significant amount of time to port an application from database X to database Y. It was true 10 years ago when you tried to go from Sybase to Oracle. It is still true, and it will still be true 5 years from now when you try to take an application from Cloudera Impala onto, say, Drill or something else.
Alan?
All right, so this might be the only time you get to hear me say this tonight, but I definitely agree with Justin on, on his approach here of you shouldn't just chase the you know, the standard for the sake of the standard. We're going out there, we're hearing what people want, we're adding those things in, and when we do that, we're working really hard to make sure they're ANSI compliant, right? We did just add the windowing functions as an example to Hive that came out in Hive 11. We made very sure those were, you know, those met the appropriate standards in SQL. And Hive, of course, has some technical debt in that term, in that area, as far as going back and fixing things like the data type model and those kind of things, which is also ongoing work in Hive. So I totally agree. It's not about making everything SQL compliant. I mean, I don't think we're ever going to check that box that says we do everything you could think of to do in any of the SQL things. I don't think there's any meaning in that. But what there is meaning is making sure when you tell people, hey, you can do rollup or you can do rank or whatever, it works the way they think it's going to work.
Okay, so I'm going to move on. But for those of you young people who don't know about SQL, this is known as the SQL standard tap dance. Okay? All righty. The next question, and we should go hit these quickly because I know Ravi wants to get questions from the audience now. On-prem versus cloud. Quickly, what are your thoughts? Are you focused solely on-prem, solely cloud, both? What is your vision of where it's going to evolve in order? Sushi?
So enterprises today don't want to share data on the cloud. So they're all on-prem, majority of the customers, at least what we are talking to. And the next big thing which we are seeing is private clouds.
SQL Azure would beg to differ. Alan?
Both, very much. I mean, we see people that want to do it in the cloud, people want to do it on-prem, people that want to mix and match private and public clouds.
Tomer?
So I think I'm kind of in a unique position here because MapR is the Hadoop distribution of choice for both Amazon and Google's clouds, and nothing bad about Azure here. You know, we've been running on Amazon for the last year through an OEM partnership with Amazon, and you know, have accumulated hundreds of customers that run our platform in the cloud. And I think the use cases in the cloud that you see are pretty similar to what people do on premise. The way they keep the data, you know, there's some differences there, and I think impact that has on the SQL tooling is that, for example, you have to be able to run a SQL query that can query data on the local on the local HDFS, but also be able to take dimension data or fact tables from S3 and other cloud storage systems, Google Cloud Storage and so forth. So I think there's it's important to make sure that the tool that's being developed or any of these SQL tools have that capability with kind of pluggable storage interfaces that they can actually connect to those different sources.
We're running into the stretch run, so I'm going to ask people to be brief. Justin?
I keep it quite simple. I think there's definitely both. I mean, I don't think that this cloud is just a hype thing that's just going to disappear. There's plenty of enterprises today that put their data there. I think there is an important thing when you look into your Hadoop system that there's a center of gravity, and where's the data getting generated from, and that's going to be a key weight. If a lot of it's getting generated from your local data center, you're probably more likely to do a local deployment. If you're getting it deployed from around the world, now you have choices of, do I maintain my data center or put it into the cloud?
Priyank?
I think we'll see Hadoop take a little bit longer in that tradition, given the center of gravity, but it's clearly a part of our strategy.
I think we also view it as if the data is being generated on the cloud, it tends to be a wish to actually analyze it in the cloud. Although we have customers who actually have pretty big operations on AWS, and yet the data is brought on site into Teradata databases for analysis. Case in point, Netflix.
Okay. The last question is clearly going to be controversial, so let me frame it in a more pointed way. I'm not sure how long we're going to have the luxury of referring to the Hadoop, because already I see, OSS, sort of OSS, proprietary, backed by something that matches the OSS API. All these variants are happening. How many people think there is going to be a Hadoop standard that we will all agree to and conform to over the next few years?
I think we have to have that. I mean, that's what customers want. I've talked to hundreds of companies. They do not want to be locked into a specific vendor. That's critical to them. They want to be able to move between different Hadoop distributions, and I think we're all going to have to.
How is that going to coexist with the open source philosophy of development?
Well, I think it's already working. I mean, you see 3 different distributions, or maybe more distributions just here at the table, and the reality is that customers are moving between them. And this has been going on for the last 2 years, and I don't see that changing anytime soon.
I think that standard is Apache Hadoop, right? I think if you try to put this in some kind of standards body, it's going to calcify and die. Those things just don't move at the right speed. Open source moves at a speed vastly faster than those standards bodies, and so I think by default Apache Hadoop is that standard and will continue to be.
I'd also look and say that when you're the key thing of the open source movement is the ability to have the flexibility of trying out the technology, using it, and deciding your support model afterwards. While some of these things you can move between, when you do and you're making a bet for your big data system, moving petabytes of information, that's not an easy thing to just move between other systems.
So what is the standards body going to be? You can't have a standard without someone ratifying it. What is that going to be?
So, I mean, I would agree that Apache Hadoop, in terms of the file system and the core of that, is the core way to go and store your data.
Beyond the file system, there's an entire ecosystem. What are the things that we need to standardize?
So you have the distributions that are building that out. So you look and say every one of our distributions include Apache Hadoop, include Pig, include Hive. Most of them will include Mahout. All of them include HBase. And the fact that multiple of these vendors are pushing this forward and starts defining one of the standards around that.
Sushil,
we would love to see interface standardization. So this is about how, for example, HDFS API standardization, so that you can have plug and play technologies underneath. SQL, a standard very similar to that should be.
So who would do that? Apache?
Apache should be doing that in our.
Tomar, what do you think?
I think, like I said, I think it's already happening. I mean, it's the standard is the Apache. The Apache projects are the standard, right? And you look at all these distributions. I mean, we all have Hive and Pig and Uzi and Flume and Scoop and Whir and Zookeeper. I mean, there's so many projects here. I don't think there's going to be like a standards body now defining interfaces, but I think the market forces are basically have dictated to all these companies here that they have to be compatible, because that's what their customers want, and that's what's good for all of our businesses.
So what you're basically saying is what happens in Apache is de facto the standard, and we don't have to do anything more.
So
I mean, it's a standard API. That doesn't mean companies can't innovate. I think one of the things that's been super important to us at MapR from day one is taking all the open source innovation that's happening, bringing that to our customers, and then also adding additional innovation. And as long as we can do that innovation underneath the well-defined APIs, customers get that innovation, without introducing any lock-in or any of those types of concerns.
Quickly, Justin.
Yeah.
And then
I'd say that it's not necessarily that the standard is run by Apache. It's more important that your big data platform is open source, and that's the driving factor. And the standard is really decided by the market rather than by a standards body. And so as you see more of these technologies get adopted by customers, whether it's adopted through CDH or whether it's adopted through the raw projects or other distribution, that's what drives the actual standards, is the market and the customers drive that. And you can see examples of great standards that have been developed in open source, such as Linux, such as MySQL, such as PostgreSQL, that had other ways and other governance models that they've gone and administered across it, and the market has resonated very strongly with that. So I don't think that it's necessarily Apache. We at our Cloudera definitely view that the value of open source is critical when you're making a strategic and fundamental platform infrastructure decision, that you do not want to make a decision where you're locked into a proprietary license.
Priyank?
We think open source needs to have a community. If you try to lock out the community and just say this is open source because I put it on GitHub, that's not enough. That's for sure our view. That's it.
Okay, on that note, let's thank the panel and open this up to questions. Okay, please.
So I'd like to ask the panel to resolve the conundrum that SQL has a standard and has no compatibility, but Hadoop has no standard, but has essentially perfect compatibility. What's the answer to that conundrum? How does that happen?
So Ravi, should I repeat this? Yeah. Okay. So the basic question, SQL has standards, but it's very hard to switch between vendors. Hadoop has no standards, but amazingly people are switching at will. So explain this.
Open source rocks.
Okay, any other answers?
I think there's one thing with SQL. The kind of applications which have been developed and are running on SQL have been around for a long time and are very mature. So by nature of them being around for a long time, they are extremely complicated and rely on very vendor-specific extensions to the standard that the vendors have made. Hadoop is relatively new. The applications are being developed, but they are not such that I utilize this very
basically when there's no legacy, standards don't matter.
Exactly. And I think it'll start
more questions, please.
Can I put another piece on that?
Please.
I'd actually say that the challenge with a lot of the movement is when you look at the Sybase and Oracle example, you're actually moving data. And so I'd actually say that it is actually hard to move data once you put it into Hadoop to another non-Hadoop system. The value and the difference on the SQL side and why is that in this new world, the SQL engine is actually decoupled from the storage engine. So it actually is much easier to be able to move between the processing frameworks than it ever was in the past, as the storage manager, the query engine, and the metadata store are now decoupled.
Next one.
My question might be slightly misplaced, but since we are at NetApp, I just want to toss this out. So, whenever we are talking about this big data paradigm, we are always, limiting ourselves to, the database. Why haven't we explored going down till the data storage paradigm? I want to optimize my data storage because we, talking about Tomer's point, we also have multi-tenancy. NetApp offers multi-tenancy. NetApp offers HA. Why not devise these applications that directly talk to the box instead of having this middle application that diverts how, and you guys don't know how, I'm not saying you guys don't know, but.
You're saying it, that's okay.
But I just want to
You're
be careful.
talking to them, right?
Yeah. But I'm just curious, why don't we address this problem of performance from ground up instead of circling around SQL, NoSQL?
So interesting take on your answer would be that.
Let me actually repeat the question.
Sure.
The basic question is, since the storage tier NetApp being an example,
Exactly.
already is supporting a lot of the things that you claim you're getting from the tier above, namely SQL.
Yeah.
Why fudge around with SQL at all? Is that a fair?
Yeah, that's, I think, a fair
Okay.
interpretation. But
Please.
So, I mean, I was trying to say that if NetApp has got so many, let's say, enterprise capabilities built into the storage system, NetApp should look into exposing
oh,
HDFS
we should build
and
those apps? Are you suggesting that?
not the apps, the interfaces, so that you support the standard interfaces and the
Okay.
apps will migrate over to any platform, whatever they prefer.
Okay, okay. So, the only answer that I receive is that we need to expose more APIs so that, because I'm partly
So let me
still.
rephrase that. Okay, so let me rephrase that.
Oh, is it? Okay, cool.
Basically, what he's saying is, if you believe you have API compatible functionality to the tier above, expose it and make a few more billions.
Okay, I'm going to think
Okay.
about this. Thanks.
Alrighty, next.
Hi, my name is Ramesh, and since you guys are talking about SQL, NoSQL, I had especially you go to SQL, you got normalization, indexing, you got to know what people will be looking for, which field people will be looking for, you got to index on that. So I'm just thinking that if you have done any metrics on making the structured data to unstructured data and see if it will deliver faster results. Because right now Hadoop is only, earlier you were looking for like logs and all the unstructured data, and you don't want to have lots of data. So let's have like some database, you just unstructure it and use Hadoop and see if it will deliver faster. Do you have any metrics for that?
So what is the A and the B in your comparison? A is unstructured data over which you run some Hadoop processing engine.
And you have a database, an Oracle or SQL Server. We build indexes and normalization and all the stuff. So totally unstructure it and see if Hadoop can get the speeds of the thing that they're claiming for. Have you done any metrics of unstructuring the structured data and running Hadoop on it?
Of taking structured data,
Destructuring
storing it simply as a flat file and getting
Yes.
numbers?
Yes.
Yeah, there are plenty of numbers. Anyone want to speak to that?
astrodata.com/ESG. There's a benchmark. You can take a look at it.
So, I'll just offer a brief comment and then we should move on. The bottom line is, if you were to do such a comparison, you'd almost certainly find that pretty much any standard database with indexes and the like would run much, much faster. And the point is, so what, right? That's not the design point.
Okay.
That's what I said too. I mean, we're not trying to build another data warehouse or another database. That's not what Hadoop is about, right? Hadoop is about storing big data that can't be stored in these other systems, right? You can try to store a petabyte in in your Oracle database. I think it's going to be very hard to do, right? And you're not going to be able to run your MapReduce, your Mahout machine learning algorithms, and you're not going to be able to run your pig scripts, and you're not going to be able to do all these other things that people do with Hadoop in all these other use cases, right? So yes, SQL in isolation. If all you're planning to do is build a SQL data warehouse or a database, then I'd suggest you go look at Teradata or Oracle or one of those systems. But I don't think that's the objective.
Well, there is another way to address that, right? If you look at all the work that pretty much every company at this board is investing in to build a SQL engine on top of Hadoop, then you can view that as an attempt to take some of the same ideas behind a modern database implementation and graft them onto data stored in this setting, and dealing with all of the complexities of greater diversity and so on. But at the same time, when your data happens to be more or less structured, to give you performance that's compatible with what you see.
Cool.
Right?
Thank you.
So it's underway, I would say.
Sure, thank you.
Can I add a quick thing on that?
Please.
Yeah. So I think one of the key things here is this is not an exercise in trying to find cool technology just for the sake of it. We're trying to find the solutions to sets of problems. A use case where that actually is useful and why there are technologies such as Scoop, which brings data between SQL engines and Hadoop engines together, is being able to combine the data that comes from your transactional processing systems with other sets of data sets. And we see a lot of use cases of people taking the core transactions that are being bought and sold, using Scoop to bring them into a Hadoop system, and combining that with other large data sets to now get other insights. Again, coming down to what I was sort of alluding to before of combining not just the bought and sold transactions, but the interactions that happened that led up to those to see if I can encourage more behaviors to lead to the revenue generating system. And that's why it's useful to be able to take the structured data and bring it into Hadoop. But it's not just an exercise into just pulling data for the sake of pulling it.
I agree with that, but it's not just transactional data, right? If you take all your logs, it may be unstructured to begin with, but a ton of analysis on top of that using SQL would be in the structured form of it.
Absolutely.
So, next question, please.
Hi, I think I'm sort of paraphrasing what some of the other people have said. It seems like, I like relational, great. It seems like this is sort of an attempt to legitimize SQL in a non-SQL world to some extent, in the sense that if the majority of data out there were SQLizable, if that's a new verb, then Facebook and Twitter and all the rest would be embracing it. So what I'm trying to understand is, to what extent is the exabytes and petabytes of data out there going to be SQLizable? And I think my impression is it's going to be the minority of that data, 10, 20%, I don't know what. So what's your sense of that in terms of the value proposition of SQLizing data in the non-SQL world, if that makes sense?
So the question, if you take all that data out there that's not already in a relational database, what fraction of it is going to benefit from all these efforts to provide support for that data viewed as relations even when stored on Hadoop?
Correct.
Okay. Priyank, and then down the table.
So I cannot make a forward-looking statement saying 10 years from now, 20% of data is only relational.
Just today.
Or relational. But I can make an observation of what we've been seeing with the data sets that are associated with unstructured data. Almost a lot of the data sets that people are interested in analyzing have what we call an evolving schema, where the schema exists. It's as was pointed out earlier, the schema is there. It's not that it's fully relational or fully unstructured. It's somewhere in the middle, and it evolves very quickly. It may be that in the next month, the data feeds will suddenly have 2 more fields which are changing very, very fast. And so systems which deal with this evolving schema are important. Whether they use SQL or not comes afterward.
And that's actually a good point, because that's exactly the design center for Apache Drill, is the evolving schemas, right? It's that JSON file that I'm not going to go and define in a different system what that schema is and make sure it's always up to date, because tomorrow, these JSON records are, they could have another field added to them, right? So I just want to grab that file and I want to run a SQL query on it, and that's why we've designed Apache Drill to be able to do that without predefining that schema. So that's really, we see Drill as bringing SQL to this world of data that's kind of semi-relational, if you will, does not have a fixed schema that never changes.
Alan, you wanted to comment?
Well, I think I wanted to go along with what Priyank was saying, but I would also say it's not just that it's not an attempt to legitimate SQL in these things. It's that as Hadoop grows its user base, I mean, SQL is the English of the data world, right? Everybody knows SQL. And Hadoop grew up in a world with experts that could program in Java and get paid to do that, and frankly like to do that, and weren't particularly motivated to make it easier to use, right? As it spreads out, that becomes less and less true. So it's not about legitimating SQL, it's about opening up the power of Hadoop to more and more people. But I think I'd like to echo what the other people have said, is that I'd actually like to cast a little differently, but I think it's the same idea. There isn't really unstructured data, right? We call it unstructured, but all data has structure, or it's just crap, right? It's just sitting there.
Yes.
It may not be relationally structured. Correct. It may not fit well in your database, but that doesn't mean it doesn't have structure and meaning, right? And so I think SQL can still be a very good tool for getting at some of that. And obviously all these other tools are going to be useful too, but I think the other tools are more useful when it comes to different paradigms more than different types of data, right? I think it's more about, are you trying to do graph processing or ETL or analytics, right?
Thank you.
Great, thank you.
Next one.
Hi, my name is Guru Eleshwarappa. So basically, I have a very simple question. Can somebody talk about the performance of SQL on Hadoop? The reason being, I'm asking a straight question from my customer. So they have a SQL implementation today that has a lot of limitations. So one of them happened to be it doesn't scale in terms of storage, and they cannot budget the storage, and they cannot come up with the budget for the storage. The third piece is when they do a search, it takes days. So they think that, or they ask us to move their data to the Hadoop. But now that I just came to know that SQL is going to run on the Hadoop, can you comment on how it can impact the performance? Does it degrade or does it improve or whatever? So I just want to hear from you what your thoughts are.
So I'm going to summarize that as, can you provide pointers to resources on benchmarking of SQL on data stored in Hadoop? Is that a fair summary?
Yeah, something
okay.
like that.
There has been a fair amount of work on this, so hopefully people can give you pointers.
Yeah. So I can, if you look at some of the blogs that we put out around Impala, comparing it to the latest generations of Hive and just comparing it to the numbers that you're able to achieve, the more important thing is actually getting those responses back in seconds. There's blogs that we have. In terms of what to go and consider with this, and one of the design considerations that we had very early into Impala was not just how well do you do with a query, but how well do you do under concurrency, and can you continue to achieve linear scale? So if I add more machines, do you get more concurrency, and do you get more throughput, and can you maintain and toggle the amount of latency you can get with that? And you'll see some that's available now and some that we have, but have not actually gone and published some of those things. One of the interesting things and one of the challenges here and the differences between the open source vendors versus the proprietary vendors, proprietary technology, you actually can't. You can't use that technology until you've paid them money, and at that point you're sort of locked in. And most of them have clauses that prevent, in fact, the proprietary vendors at this table have clauses that prevent us from actually publishing numbers. We actually have some great numbers that if my colleagues at the table would like to change their licenses, I'd be more than happy to go and publish some very
interestingly, this is something that is worth pursuing further, because I know organizations like the TPC are interested in this space and what does it mean to define benchmarks. Yeah. So even if you don't agree on standards, having some level playing field for comparisons would be good for all of us. Yeah. There's something we should talk about.
Some of the challenges, there's different folks.
So maybe one of the things I would suggest is those of you who have numbers to share, maybe just on whatever you have done, send me pointers and we'll make them available so folks like Guru can look up how your systems do.
Yeah. If you don't mind, I just have a follow-on quick question. So do you guys have guidelines how to move the stuff from the legacy SQL implementation to whatever we are talking about here? So is it listed on your websites and things like that? So can we go and check it out, or
sure? I mean, there's a few different options in Hadoop on how to move data between Hadoop and other systems like relational databases. There's one option. There's an open source tool that's part of all the distributions called the Apache Scoop, and that's a tool that does that. I think one of the things you have with at least with MapR, we provide a standard POSIX storage layer which lets you mount the cluster, and you can use the standard tools. If you're exporting from Teradata or any other system, just use the standard database tools to export to a file directly into the cluster.
And some systems let you just run a SQL query as long as you mount the HDFS file system and make it recognized. So Hawk, PDW, these are some examples of systems like this.
Thanks.
Okay.
Could I add
next? Yeah, please.
Quick thing there? So one of the things too, I mean, I'd be happy to help work with you as well in terms of the EDW rationalization play. We have a lot of customers trying to move different systems off. So we have things that I can work with, I can chat with you afterwards. Another company to consider is not just about moving the data, it's figuring out which things can actually run in these systems, what are your expectations in terms of performance from that, and optimizing the right system for the right thing to keep the high value data in your high value and the expensive systems and the other pieces there. There's a company called AppFluent who's a partner of ours, I believe probably partners with some other folks here, that they will actually analyze some of the logs that are coming out of these systems and help you through that process. But in general, we've had a lot of experience with that, so I'd be happy to chat with you afterwards and give you some pointers on how to make that work.
Next one.
My question is with the Hive server to JDBC connection and the more SQL compliance. Now more and more tools and more users who may not have a Hadoop background, who don't know how the Hadoop works, will be executing a lot of queries against Hive or other SQL. So are we like opening the floodgates without actually preparing for it? Do we have like resource management and other things in place before opening this floodgate? Yep, that's.
Sorry, can someone paraphrase the question?
So I think the question is, can we handle the workload, right? Do we have the tools necessary if you've got 100 users on your cluster and they're all throwing SQL queries at it? Can the cluster manage it, or is it going to fall over?
Yeah, especially they don't know the concept of Hadoop or MapReduce. Like they're coming from a traditional SQL point of view.
They're not writing the queries with MapReduce in mind, is what you're saying. So, all right, I think it's fair enough. Definitely the tools can handle. I mean, Hadoop has, there's lots of installations with thousands of machines and hundreds or thousands of users. So concurrency is certainly not a problem in Hadoop. I think it is true today that you still have to be a little bit mindful of the underlying, at least the way your data is stored, to write good queries in Hadoop. Because you can goof up and end up doing a full table scan without intending to. I think there is a little bit of work to do there. But I don't think that Hadoop itself needs to worry about the user load. That's actually one of its very strongest points.
So the different perspective on this one is that if your queries run faster, the multi-tenancy issue is also a smaller issue, because you can have many more queries running on the same platform. That's what.
Still need multi-tenancy. I mean, you're going to have different groups and different departments and different types of data of different, importance and PII, and there's no way around that. You have to have the ability to support different groups.
I actually heard two parts to your question. Are there tools to manage Hadoop clusters? Answer is basically yes. And the other is, what happens if people write queries without really understanding what they're doing? And the answer is good luck. There's no easy answer. Hadoop is not going to be a panacea for that.
But I think that some of the platforms do provide the ability to control how much resources each user is getting and each group is getting, right?
Sure.
I mean, you have those controls, and so it's not like, if you do set it up properly, then you're not going to have a situation where the new intern that just came in ran a query on the 5 petabytes of data you have in your cluster, and you're now down for the week, right?
So but if you have the authorization to run a large query, which you probably do if you're doing production work, and someone writes a query using that authorization that's not supposed to be heavy duty, you can very quickly spend a month's budget in a day.
You can.
Yeah, just one more, just a short follow-up question. So with all this interactive analysis given priority, is there any thought on giving intermediate results to the user before the actual query finishes?
So early presentation of results.
Yeah.
Anyone want to comment on this? So basically the scenario is you have a query that is going to take a long time. So it's not quite interactive, but you would like to give them partial results, so maybe they can say, cancel this, or at least have some sense.
I was going to say, one of the things we've designed with the Apache drill in terms of the operators is building some of these operators to be approximation operators. So, that's where you get a result that isn't necessarily going to be 100% accurate, and you're okay with that, and that can be returned a lot faster. So then it's just a matter of multiplexing it so that you're getting both the approximate results, and later you're going to get the full results. And definitely something you can do.
Sakshil, did you want to say something here?
Yeah. So one of the things which you could look into is having pre-populate the data with some statistics on the tables. So this way you don't even have to run the query. You can just look at the statistics and figure out what you're looking for.
Yeah, my problem was for example, I'm scanning a user for 2 months of data. If the scan is done for 1 day, I can see the results and work on it till it's done. 2 months is already done.
So the bottom line is, I think this will happen, and it's beginning to happen, but it's in the early days. There are research projects at places like Berkeley, BlinkDB, and there's also lots of work in the traditional SQL world on so-called online aggregation. And now that we're all on the train of looking at SQL as a tool on top of Hadoop, I'm sure all of these will follow.
Thank you.
Okay, please.
So I took a break from Hadoop for a little while, and I came back because I thought I'd write an optimizing SQL engine, which I did, and it was great fun. But it's slightly depressing to come back to Hadoop after some number of years and find that I'm working around exactly the same bugs as I was working around 3 years ago when I last coded for Hadoop. Things like configuration keys that don't have a well-defined meaning or are used in multiple places to mean different things. Well, now you've got to pick a value for that configuration key that works in all of those locations. Is it the bind address or the connect address? And it seems to me, listening to the presentations, that the development of Hadoop itself is moving incredibly slowly. I've heard development compared to the speed of continental drift. And and that most of that development is going in the direction of fragmentation. We've heard 20 different interfaces and APIs presented here. And so 3 years ago, when I had the problem of coding for 3 Hadoop APIs, now I've got the problem of coding for 10 or 12 Hadoop APIs. Hadoop should be a dead cert for all of the big data processing. And Yarn or SunGrid Engine or LSF or whatever name you care to know it by, you know, this generic job scheduler framework that we've all been dreaming about, should be a dead cert for all of this stuff. But it's not the case. So this is making me look very much outside Hadoop for my default big data platform. I'd like a response to this, please.
All righty. So let me paraphrase that question. The lack of standards and the fact that there are still all of these inconsistencies in the code base and how Hadoop is evolving make me leery of depending upon Hadoop. Is that a fair?
Thank you. Well, any bug which is present in all 3 major vendors Hadoop, yeah, I'll put a standard workaround in for.
So, do people want to respond to that? I mean, this is a counterpoint to the earlier sense that we had from some of the people here that it's all working great anyway, that we have standards that are sort of evolving and are satisfactory. I guess he would disagree.
So I think when you look at this, it's kind of the goal of why any one of us came into the distribution space is you have, let's say, 13 or so different projects that you need to figure out the cross matrix of how they work and get that up and running. And the goal of a distribution is to be able to collect the things and say, hey, this works as an end-to-end system. The challenge that we're running into is you kind of get the push to go and say, I'm going to continue to work inward, and you get the push to say that I need more processing frameworks on top of that. I empathize with the pain that you're running through, and there's by no means am I going to go and claim that this stuff just easily works right out of the box. But I think that is sort of it is definitely a glass half full approach. I would claim that there's a lot of great developments that have been going on in Hadoop, and in terms of the ease of getting systems deployed, you get technologies such as Cloudera Manager, and each one of us have our own management suite that go and say, hey, what you want to do is you don't want to go and configure this particular configuration value. You want to get HDFS up and running, and you're trying to specify doing this particular action and being able to up-level the problem so you're not managing individual nodes and individual processes, but you're managing an overall service. There's absolutely more work that we can do within that space, but as I'm looking and working with customers that are deploying today versus a year and a half back when I joined, there's a marked difference in their ability to go and do deployments within that. Another one of the challenges you're running into.
Let's take a time out on this. This is one that could go on for a long time.
Give me 20 seconds on that one, though.
So okay, I'll give 20 seconds to you and 10 seconds to you. 5 seconds, 10. Okay, 10.
So first of all, welcome back, Shivek, to the Hadoop community. Why don't we do this? You're not a paying customer of MapR, but if you send an email to support@mapr.com, you'll get a fix in 24 hours for that bug.
All righty. So do we have a similar offer from you?
No. The way I describe it is that Hadoop is like a box of sharp knives. What you want to do is a lot more investment needs to come in from the open source community, and we all together to make it easier for users to manage. And you're describing the typical user pain.
Okay, let's take this offline. We are pretty much out of time, so one last question, please.
Okay, so my question specifically about all the online, query processing engines that are kind of people are working on, and there's a lot of good work that's happening. But here's the interesting dichotomy I see, right? All on one side, there's this entire discussion of polystructured data and semi-structured data and sort of complex processing that was kind of not possible with SQL. And then when I go and look at all the benchmarks that people publish, it's with very structured data on simple group by queries, right? So the point still remains that there's this picture of, oh, we have a lot of polystructured data. We're going to do lots of complex processing on this polystructured data and sort of enable a whole new class of applications. And then when you come back to the online SQL world, which is sort of a big theme of today's discussion, everybody is still publishing the same sort of small benchmarks, group bys, simple aggregations, and so on.
So the summary here, everyone talks about polystructured data and fancy processing, but the benchmarks are still the same old, same old. What gives? Short answer, we need to address this. Some people are thinking about benchmarking for machine learning and the like, but we need to do a lot more on this. With that, one more question. Sorry to be so quick here, guys. People are waiting for dinner.
Went through a crest and trough in my excitement about SQL support on Hadoop, and that was at the point. The trough was when you said good luck to the other gentleman. All of you said one of the key reasons for migrating to SQL on Hadoop is that we want to be able to support what has been already built for a long time on SQL. And then when you say good luck, it means that those guys are not going to redesign everything, right? And most of you answered that yes, things have to be thought of in terms of MapReduce, which makes sense, which made sense even earlier. Now, does that mean saying SQL and Hadoop is just another sell for the enterprises, and then finally you say that you have to redesign stuff?
Actually, since I said good luck, let me clarify that. My comment was not, if you take a SQL program that runs on your SQL database, and happens to be a reasonable query, if you run it on SQL on Hadoop, and if it doesn't work, good luck. That was not my intent, right?
All right.
If you run a random program that doesn't run well on your SQL system and expect it to run well on SQL on Hadoop, then good luck. That's really all I intended.
So, but the BI systems, because these were the questions I was having, the BI systems which have been designed, they can issue any type of queries, right? And you're saying there's some kind of queries which might take longer time, some which will take shorter time. The BI systems cannot distinguish between those things when they are designed, right? So how do we address that?
So let me take that. When I said that, today you still have to know a little bit about MapReduce underneath to write the good thing. That I want to stress the today part of that sentence, right? Obviously, that's not where we want to be. When in my slides, when I did the intro thing, you noticed in phase 3 was a real cost-based optimizer for Hive, right? You're exactly right. You can't expect either systems or most users to understand the underlying structure of your data or the underlying way your system works and how to order their joins to get the right thing to happen, right? That's not acceptable. So when I said that, I meant that's where we're at today. That's not where we want to be, right? And I think that's important to understand.
Sounds good. Thank you.
Yeah. Great. So thank you all. And it's wonderful being here. Thank you all. Thank you. Great job, guys.
Thank you, Raghu, and all the panelists. This has been, we thought it was going to be Clash of the Titans. It's more like a love fest here. Pashu, do you want to come over? So our great friends at O'Reilly have some things to give away, so I'll hand it over to Pashu.
So good thing you stayed till the end because we have some great prizes. So Katie is gonna, is gonna take a card from the ball. Maybe you can tell you one.
Well, I just want to thank Pashu and Ravi and Hive for having us. And thanks for staying until the end, and thanks for stopping by the table to talk to us. So we have, as we mentioned, 3 books to give away, and then the grand prize is a free pass to Strata Conference and Hadoop World happening in New York this fall. So without further ado, I'll do the drawings for the books first, and you have to be here. I guess if you're not here, you're not here. But you have to be here for the prizes. So the first book will be for Hadoop, the definitive guide. And the winner is, it's very exciting, Gene Davis of Splice Machine. Is Gene here? Yeah. Great. Come on up or down. All right. Congratulations. The second book we have here is a High Performance MySQL. And the winner, I'll try to mix it up real good, is Mark Grover of Cloudera. Is Mark here? All right. Was that Mark? Is that Mark? Okay. Great. I'm glad. I like it when the winners are all here. Congratulations. Enjoy. And the last book here we have is Hadoop Operations. This is from a Cloudera author, Erickson, very popular book. And the winner is Ellen Friedman. Is she? Oh, Ellen. Okay, and then the grand prize, the pass to Strata and Hadoop World in New York, goes to, if this person is here, Atul Chawla of StratApps. Hi, congratulations! All the winners are here. Great, thank you so much.